Hello, and welcome to our second presentation assignment for this course ELL212. Before starting, let me ask you a question. Do you know how much are you dependent on electricity? Have you ever experienced a power cut that lasted 8 to 9 hours? If you experienced this in summer, you would know what station is. Now just imagine this electric cut goes on for another 6 hours, 12 hours, or even a day. It would be a nightmare for some of you. But in the grand scheme of things, that's nothing. If a power cut hits an entire city and there aren't adequate emergency resources, then companies may suffer huge productivity losses, tons of food may spoil, and people may. If a power outage hit on a much larger scale, it could shut down the electric networks that keep governments and militaries running. So, we are utterly dependent on power, and when it's gone, things get bad very fast. So, an electromagnetic bomb, or E-bomb, is a weapon designed to take advantage of this dependency. But instead of simply cutting off power in an area, an E-bomb would actually destroy most machines that use or generate electricity. Generators would be useless, computers would not work. There would be no chance of making a phone call. In a matter of seconds, a big enough E-bomb could basically make an entire city or military unit cripple. The basic principle of an E-bomb or an electromagnetic pulse weapon is pretty simple. These sorts of weapons are designed to overwhelm electric circuitry with an intense electromagnetic field. The most important thing to understand about electromagnetism is that electric current generates magnetic field, and changing magnetic field can induce a current. This magnetic field in turn can induce an electric current in another conductor, such as radio receiver antenna. If the fluctuating electric signal represents a particular information, the receiver can decode it. A low-intensity radio transmission can only induce sufficient electric current to pass on a signal to a receiver. But if you greatly increase the intensity of the signal, the magnetic field, it would induce a much larger electric current. A big enough current would fry the semiconductor components in a radio, disintegrating it beyond repair. So, there are two kinds of EMP threats, nuclear EMP threats and non-nuclear EMP bombs. The idea of nuclear EMP threat dates back to nuclear weapons research from 1950s. In 1958, American tests of hydrogen bomb yielded some surprising results. A test blast over the Pacific Ocean ended up blowing out street lights in parts of Hawaii, hundreds of miles away. The blast even disrupted radio equipment as far as Australia. Researchers concluding that the electrical disturbance was due to the Compton effect, according to which photons of electromagnetic energy could knock loose electrons from atoms with low atomic numbers. In the 1958 test, researchers concluded the photons from the blast intense gamma radiation knocked a large number of electrons free from oxygen and nitrogen atoms in the atmosphere. This flood of electrons interacted with Earth's magnetic field to create a fluctuating electric current, which induced a powerful magnetic field. The resulting electromagnetic pulse induced electric currents in conductive materials over a wide area. Nuclear EMP affects a large area and can't be used on a local level.
Now we will talk about non-nuclear EMP weapons. Much of the India's EMP research has involved high-power microwaves. EMP bombs are like super powerful microwave ovens that can generate a concentrated beam of microwave energy. One possibility is the SPM device would be mounted to a cruise missile, disrupting the ground targets from above. The bomb consists of a metal cylinder called the armature, which is surrounded by a coil of wire, the stator winding. The armature cylinder is filled with high explosive and a sturdy jacket surrounds the entire device. The stator winding and the armature cylinder are separated by empty space. The bomb also has a power source such as a bank of capacitors which can be connected to the stator. So, how does a non-nuclear EMP bomb works? Firstly, a switch connects the capacitors to the stator, sending an electrical current through the wires. This generates an intense magnetic field. A fuse mechanism ignites the explosive material. The explosion travels as a wave through the middle of the armature cylinder. As the explosion makes its way through the cylinder comes in contact with the stator winding. This creates a short circuit, cutting the stator off from its power supply. The moving short circuit compresses the magnetic field, generating an intense electromagnetic burst. So, what are the effects of an EMP attack? EMP technology is potentially non-lethal but is still highly destructive. Low-level electromagnetic pulses would temporarily jam electronic systems. More intense pulses would corrupt important computer data. And very powerful bursts would completely fry electric and electronic equipment. For example, an E-bomb could effectively neutralize vehicle control systems, targeting systems, communication systems, navigation systems, and long and short range sensor systems. So, how do we defend against an EMP attack? We can put our electronic devices in a Faraday's cage, which is basically an enclosure used to block EM waves. It works on the principle that the internal electric field developed by the bound charges cancels the effect of the external applied field. According to Technology Perspective and Capability Roadmap, electromagnetic weapons represent both threats and possibilities in the context of network-based defense. The HPM weapon could be used against an opponent's network and become the heavy artillery in the age of network-based defense. One useful aspect in the context of operations is that HPM weapons knock out the electrical equipment rather than people. In future, HPM weapons may be used to counter incoming anti-ship, anti-aircraft, anti-tank missiles or to prevent other ships or aircraft from approaching too closely. With this, we conclude our video. Thank you.